Right, thanks Noel. You've stolen a little bit of my presentation, but only a very, very little bit. My name is Laurence, colleague from Antennair, Carl, sat down there. And right. So I'm the hardware guy, Carl's software. Carl also happens to own a manufacturing business, which is quite handy when you look at the surface mount stuff we've got on here. Anyway, briefly a little bit about me, because I've got a 3/4 of an hour slot, and I'm rather worried that I might get this over within 10 minutes. So just very briefly.
When Laurence said that, knowing you.
Yeah. Well, very briefly, a little bit about me. I first got interested in television in, I think it was 1973, when a constructional article appeared in Television magazine to build yourself a colour TV. And every month you would make a new circuit board, and every month you would spend more of your money, and after about 8 months you ended up with a pile of bits that didn't quite work. And it was at that point I determined, having spent all that money, I would find out more about the colour decoder and all the other circuits, and I would actually fix the damn thing. So I did. I published the various fixes in Television magazine. Then I found it was a pig to actually align the thing, so I designed a grayscale generator, and I was speaking to the editor of Television at the time, and he said, "Why don't you publish that?" So I published that in the magazine, and then I got a lot of letters off people saying, "This is all very well, but do you not make something that does crosshatches and dots and all the other things?" So I ended up having a little business, in fact it was called Technologics, making colour TV test equipment. We're talking like 74, 75 sort of era, and that was quite successful. We also designed a teletext decoder for the then new teletext service, and sold quite a lot of those. So I guess that was my first taste of a mix of analog colour TV and digital technology. The teletext decoder at the time used about 120 TTL chips. It was enormously power hungry, but it worked. And one thing led to another, and 40 years later, 30 odd years later, I was manufacturing teletext decoders, but this time they had a microprocessor in them, and the output was serial, and they were quite useful for receiving things like the betting odds, and they had commercial applications. It was around that sort of era that I bumped into Carl. Carl's manufacturing factory, very useful. We started a joint development on a teletext inserter. I did the hardware, Carl did the software, and good working relationship. We thought, this is good, and it became apparent analog TV was disappearing, to be supplanted by digital TV, and we both decided more or less instantaneously at the same curry one evening that it would be a good idea if we produced a digital modulator, because eventually it was obvious TVs would not have analog tuners in them anymore. What would hotels and offices and schools and places do if they wanted to distribute video? So the idea of a DVB-T modulator was born, and this product, the DTX1, is a derivative of that DVB-T product, and as you'll see as I go through the slides, the hardware is essentially the same. It's just that there are some slight differences to the FPGA code and to the firmware that Carl has ably written. So I'll get on and explain what it is that's in this box. Don't know whether you've all seen this, but you should certainly have seen it in the magazine and on the website. This is the guts of the box. That's the actual box, and although it's heavily emblazoned with Antennair and Quadrant, that's because we had hundreds of these front panels made for the DVB-T product. So it's not exactly blatant advertising, it's just using the box that we that we had done for the volume DVB-T product. So I shall crack on. So I wasn't quite sure how to pitch this presentation really. I thought I'll just do a very brief sort of romp through the top level of it all. I won't get in too deep. If anybody wants to ask questions, either myself or Carl, very happy to take questions after the short presentation or later on in a side room. We've actually got all this kit wired up and you can see it working, and again, ask questions if you'd like. So to start off with, what is DVBS? Well, it's digital video broadcasting developed for satellite, whereas the T is developed for terrestrial use. The modulation scheme for DVBS is relatively simple. There are 4 points in a constellation. There are only 2 variables being played with here. There's the position that the signal arrives in time, or the phase of it, if you like. It's phase shift keying. And there's the amplitude. It can have one of 2 amplitudes. So you've got 2 parameters that can only each have one of 2 amplitudes, which is 2 bits. So that's what this means here. Each point in the constellation represents, for example, I'm never quite sure where it starts, but let's say that's 0, 0, that's 0, 1, that's 1, 0, and that's 1, 1. I might have got that wrong. It might start 0, 0 there. I'm not sure. But the upshot is that we can transmit digital information by fiddling about with the phase of the carrier and the amplitude of the carrier, both at the same time. So if you'd reduce one, it moves that way, one the other, and so you can zip about either any or all combinations of these. Now it turns out, mathematically speaking, that the actual bit rate, or rather I should say the actual bandwidth, not the bit rate, the bandwidth that this occupies in a TV channel is about the same as the symbol rate. So for a satellite transmission, you might be talking about 27 million of these per second, which would equate to about 27 megahertz or 30 megahertz satellite bandwidth. Oh yeah, but I should point out, this is an actual shot, or digital extraction, that is, from a nice piece of kit made by Rohde & Schwarz. But at the time we developed this, we didn't have the money to buy anything like that, and we were very lucky to be allowed a day down at the BBC Labs in Wood Lane in London, and they allowed us to come down and test our early DVB-T kit. And in fact, this is the DVB-T modulator running in QPSK mode, which is why it's got some extra little bits appearing up there. That's some markers and things, but the upshot is that's what the waveform is in terms of a constellation. So for amateur TV use, the bandwidth that you're after is more like 2 megahertz wide, and sometimes 4, I understand, is that right? So that is effectively limiting the symbol rate that you can use to about 2 megasymbols, or about 4 megasymbols a second, which has an immediate knock-on effect on trying to get digital data over the system. Now, to get the digital data in the first place, we've got to take the PAL or the NTSC analog video and the stereo, and we've got to make what's known as a transport stream out of it. So it's an analog signal. First thing we've got to do is stick it into an analog to digital conversion chip. Luckily someone's already come up with the chip to do it, and I'll get into that a bit later. And it's designed specially for TV. In fact, it does PAL, it does NTSC, I think it even does CCAM, but we don't use it in the CCAM mode. It's not required. Now, what this chip does is it separately samples the luminance component in the composite video at the same time as it's sampling the chrominance component. It does each at about, if not exactly, 13.5 million samples a second, which results in an aggregate for the colour and the black and white of 27 megabytes a second coming out of this chip. Now, clearly from the previous slide and explanation, hopefully it's apparent, we can only get about 2 mega samples a second, which is pushing somewhere up near 4 megabits a second. There's an overhead due to the packetization and forward error correction and so on. So we're looking at maybe 3.5 megabit capacity on a 4 megasymbol channel. Is that about right? Something of that order? Clearly, you're not going to get 27 megabytes down that sort of a link. That actually equates to 270 megabits a second. It's more like the sort of standard def SDI signal, if any of you are familiar with that. So we really do need to compress it using an MPEG encoder, and the other reason why we need to compress it using an MPEG encoder is that's what the DVB-S standard calls for. So even if we came up with some other fancy compression, the receivers couldn't receive it anyway. So we're kind of driven down this route, and we're driven towards using an off-the-peg MPEG compression chip, which we found and we've used, and I'll get to that later as well. Obviously the audio needs to be processed, relatively simple, just left and right audio gets digitized, and it too gets merged in with this transport stream that I keep mentioning. I'll get to in a minute. So the chip we chose to do the video sampling and conversion is made by Intersil. Its part number is TW9910, which is an unusual part number for Intersil. We normally start ISL. Reason for that is Intersil bought a company called Techwell, and Techwell developed this TW9910 along with a lot of other stuff, and in fact they were so good at it, Intersil bought them. So the Techwell chip is now an Intersil chip, but it's retained the Techwell part number. It's a very, very good chip for doing this sort of thing. The input ADCs are actually 10-bit, even though the output is 8 bits. Might seem a perverse thing to do, but because of that, the internal processing and so on can be done at high quality, and then when the things like rounded, any rounding errors or whatever are lost in the final conversion to 8-bit. It's got very good comb filters, and the sync processing is superb. It can lock onto wobbly syncs with absolutely no problem at all. It also will accept a separate chrominance input, so you can do S-video as well as composite into it. It's absolutely grand, and it's about £4. So we chose that, stuck that in. MPEG compression chip. Little demo earlier of surface mount soldering should be enough to put anybody off trying to use something like this. It's a nightmare, but it's made by Carl's Robot Machinery, so we don't have to worry about it. We can use as big a chip as we like. It's made by Fujitsu. It happens to be the same one as is used in the SR Systems unit.
Everybody uses it.
But it's the only show in town in many ways. It's a constraint. We do know of others, but this was particularly good to work with. DevKit was available. We just got on and used that one. And it's that big chip there, right in the middle of the unit. That's the MPEG encoder. It requires a couple of RAM chips to make it work, but apart from that, that's it. It's a mixture of hardware compression and firmware compression. There is actually a 400 MIPS, is it? Something like that. 400 MIPS CPU in there screaming its head off. And in fact, in earlier versions of the board, we had quite a bit of bother stopping the harmonics from that, from landing bang in the middle of the UHF band, because I think it was running at 380 megs or something, and yeah, something like that, and it was just a nightmare. So in fact, that circuit board is something like issue 6, is it? No, there's been a lot of. that board's been respun a lot to get rid of noise, and you'll see later, and in fact I think it mentions in the magazine that the signal out of this kit is very pure. Noise is like 60 dB down on either side of the signal, which is a testament to the number of goes we had at it, really. But it's a success, I'm pleased to say. So the audio, maybe the audio and the MPEG should have been in reverse order, but anyway, the audio is a simple chip by Texas Instruments, dead straightforward. Filters on the input left and right, absolutely identical channels, Delta Sigma mod, high pass filter, and conversion to serial bit stream, and that goes into the previous MPEG chip that I referred to. Again, off the peg chip, very small, very cheap, works very well, gives you nice stereo audio. So now we've got digital data coming out of this MPEG chip at a much lower bit rate, or byte rate even, and it's actually more or less of the speed we want to send, except we need to add a couple of things to it. We've got to add control packets. The audio and the video have to be assembled into a transport stream, and then that has to go through an encoding process as per DVBS standard. Now, this is deviously complicated. I don't think it's an appropriate thing to talk about here. It'll probably drive everybody mad. I think it drove me mad just thinking about it. But the answer to how to deal with this is it's too fast to do with a processor. You need a serious amount of logic to do it. So we chose a Xilinx FPGA. I'll get around to that in a minute. The FPGA takes the MPEG from the Fujitsu chip. He then encodes it to the DVBS standard, but the output is still digital. It's in the digital domain, but it's two outputs this time. It's the quadrature that related to the grid I showed you on the first or second slide. So there's still quite a lot of analog stuff has to happen after this chip. But this chip is essentially very, very fast number crunching and messing about with data at an alarming speed. The chip we chose is an XCS31400. This is a massive pile of logic by anyone's reckoning. It's far too big in many ways for the task in hand for DVBS, but it was chosen because of the complexity required for DVB-T, which even in its simplest form has something like 2,000 carriers, each one subjected to 64 QAM modulation. It's just awesome. But having designed the product to do that, it's an easy thing to drop in a simpler bit of FPGA code to do this for the amateur market, which indeed it's exactly what it is. But you know, in there you've got 1.4 million gates, phenomenal amount of stuff for a little chip. It's got half a megabyte of RAM in there. It's got hardware multipliers, clock managers which can generate all sorts of separate clocks. It's awesome. It also has access to a library of standard parts which you can buy in or license depending on how you want to go from third-party vendors, which makes the development time less horrible. It doesn't make it wonderful, but it's less horrible. Now, at the time, as I mentioned, with this DVB-T product being aimed at hotels and the like, people that we talked to said, well, it would be really good if you could have two channels. So we might want to have one channel just running a tape explaining how wonderful our hotel is and what's on the menu, and the other channel could be dedicated to like the output of a skybox, that kind of thing. So we designed it to have another connector on the board, and that connector there is the secondary transport stream input. It goes straight to the FPGA, more or less, So that you've got one input going from the MPEG chip, another input from that connector. That's quite interesting because we're not constrained as to what we plug into that second connector. It is straight into the FPGA multiplexer, so we could do an H.264 compression card, or as indeed we have already done another MPEG compression card, and you can see that in the room along the side. We could do a teletext encoder card. In fact, I've got one where the design is complete but there's no firmware for it. We could do a telemetry capture card, any sort of data gathering we could do and make it feed into there. We could, in fact, on the forum already there's been quite a bit of interest from people about could we take a transport stream from a micro SD card, and I think the answer to that is practically yes, but it depends what the level of interest is. We'd be quite interested to know from people what they might like, how many we might make, or indeed we could make that port a kind of an open port and people could do their own thing.
The interest from that came from the fact that the Digilite product has got the ability to play a transport stream from an SD card.
So we you know, that's something that we're actively thinking about at the moment as a possible next step. But as a general rule, we're very interested to know what people might like. As I say, we're only a small company. If somebody wants to come to us with ideas, more than willing to talk about it. So here we are at the output of this monstrous pile of logic in the FPGA, and we've got two high-speed 14-bit bytes coming out of this. When it's clocked at high speed, I think it's 135 megahertz clock this thing's running at, certainly internally. And you might wonder, why do you need 14 bits when the IQ map has only got 4 constellation points? Well, the answer is, again, harps back to two things. It was designed for DVB-T, where you've got a lot more points in that constellation, so the amplitude vectors need to be scaled with much more finesse. And also, by having that many, we have the option of digital gain control. So by scaling that number, we can alter the level of I and Q that's reaching the final modulator, and thereby get very fine gradation on the RF amplitude that comes out of the thing. And in fact, we've got much finer amplitude control in the SR kit. I think, is it 100 steps, Carl, I think, you've put in the firmware? Yeah. Although as the amplitude drops, obviously the performance tails off a bit, because you're starting to bury that signal in the general noise background. So it's very handy if you're trimming antennae or anything like that, but it's probably a good idea to try and keep it in the upper 25 percentile of the output range if you can. So as I say, we've got two high-speed digital buses coming out of the FPGA. Got to get these down to baseband analog signals for putting into the final modulator stage. So we use a dual digital to analog converter. Not much choice, really. Trouble is, the output from this DAC has now got a little bit of switching noise on it from this high-speed clock and so on, which we need to get shut off. So we put good old analog filters in the way, a couple of closely matched Bessel filters. Thing about Bessel filters is a very flat phase response or group delay throughout the passband, and then it tails off quite slowly. Now, what we've actually done is we've used a slightly sharper multi-stage Bessel filter, which actually gives us a performance improvement by getting rid of unwanted noise close to the output signal, and that's another benefit of being able to do it yourself. We do what we like with that. That's the DAC. It's a nice analog device. So you've got your two digital. These are actually 16-bit inputs. It's a family of chips, I should say. In fact, we can choose, if we don't want the 16-bit output, we use 14. We can even get away with 12, I think. Have we tried 12? Not much cost saving. Yeah, so basically you've got 2 digital inputs, 2 analog outputs now, and these analog outputs are currents, strangely. They're not a voltage output, they drive a differential current out of these 2 ports here. And what we do with those is we want to turn them back to voltage, so we stick them into 50 ohm resistors, and that then immediately becomes a voltage again. But the 50 ohm resistors form a very nice drive impedance for the Bessel filters. So it's quite elegant. It goes from here into a Bessel filter and then reaches the final modulator chip. We've got another 2, it's called a dual DAC, but it's actually got 4 DACs in it really. It's got the 2 signal DACs, and it's got a couple of DC DACs in there that don't actually generate a waveform as such, you just generate a fixed amount of current coming out of here. And with these we can trim the DC offset that's on these feeds that go into the modulator, and by doing that we can null the carrier, again for optimizing the performance. And Carl's firmware, I think, does 8 spots throughout the band where we, in the manufacturing process, we null the carrier at these 8 points. So throughout the band the actual residuum carrier is very, very small. I think that's just what I was talking about there. Yeah, the Bessel filter. So the only thing we've got to do now is we've got to get the actual carrier for this final modulator and feed them into a dual balanced modulator chip, and then we've got what the whole thing was about. We've got our DVB-S RF out. Choice, again, analog devices make some very nice things. This is a particularly nice thing, but it's a bit of a monster to use because you've got to decouple it to death. It's internally running at some alarming rate and is actually capable of running up to 4.4 gigs, which you might think that's interesting because it goes much higher than 2.3. But what we've done is, because it started its life and very much still is a DVB-T product aimed at the broadcast type bandwidth up to, or signal up to 850 megs or thereabouts. We've actually got a filter on the output of this. Where's the output? There it is. Where's the output gone? Oh, RF out, there it is. Well, no, it's funny you should mention that. There are 2 outputs there, and that gives us a possibility for some sneakiness if we ever respin the board. But on the output there we've got a low pass filter, and it begins to roll off at about 1.3 gigs. And the reason it was so high is we didn't want to even worry about it chopping off the TV band, so we thought keep it well above a gig, but we don't want the harmonics of these internal oscillators coming out, so it's actually rolling off about 1.3. So this product, above about 1.35, I think we expect it runs at, will still work, and in fact the firmware allows you to tune it up to 2.1, but at that point the output is dropping because of that filter. Now there's no reason why people couldn't fiddle with that filter, but they would do so at their own peril, and maybe talk about that later. But there is an option in future to think about an alternative filter on, say, that channel, which might roll off at 3.5 gigs.
3.5 sounds a good number.
Yeah. And have a mux switching the 2, but that doesn't exist, and I shouldn't dwell on that because it's not there yet. And the board layout, the board layout isn't really well, it wasn't done, frankly, for that level of frequency. It was done with a TV 850, 860 meg. It's amazing it does this well, actually. So that's the final thing before the output socket, which some people have moaned about because it's F-type. But you know, soldering's easy. You can get that off if you want to. And again, it's because it's standard product. It's put through the production process. The robots build it, like the pictures you saw before. It comes off the end, and we re-flash it and so on for DVB-S. But it is essentially a DVB-T product. So they're your two analog I and Q inputs after the Bessel filter. So it comes out of the DAC through the Bessel filter into there. Both channels are identical and matched as closely as we can. The local oscillator goes in there after the simple, I think that's, did I say 1.3-ish, it starts rolling off into that. And that is essentially it. We do that, and we end up with that, which is that board in a box, programmed up for BATC with the DVB-S, FPGA core and appropriate software. And it's available from the shop. Good. Forgive me, I'm not really used to public speaking, as they say, but any questions, happy to take them now or later.
We've got 10 minutes.
Have you got adjustable FEC? FEC?
Yes. Yeah. Not is it 7/8 is the 5 settings.
Yeah, we'll do the full DVB-S range.
Oh, sorry. Right. Yes, you were asking about FEC, forward error correction settings. Yes, they're in adjustable steps. We've got a number of manuals in the side room. People want to have a look at those, or they are viewable on our help site, DTX1.info, which we created specially for this project, so as to differentiate it from the normal Antennair product set. But yes, it has.
What's the maximum mega symbols on it now? I can't remember.
It's 8.
It's 8 mega symbols.
You can set it beyond that.
Yeah, the reason for saying 8 is the Bessel filter starts to roll off at 10 megs. So whilst you can set the firmware and the hardware to run at 30, it'll ruin it because it's trying to get through again, they're only surface mount parts. If anybody wanted to, they could flick them off if they wanted to, or change them. But
so what does the warranty say?
It says there is no warranty, and thanks for buying it.
And some lower symbol rates?
Is it 1 mega symbol the lowest?
1024 or something, is it?
Yeah, I think 1 is the lowest, and that's to some extent, in fact to every extent, a limitation of the Fujitsu encoder. We've found it difficult to program at the best of times. That's German as well, the support for that.
To be fair though, the MPEG spec only goes down to 1.5, 1.5. So if you go below 1.5, you can't guarantee anything works anyway.
Certainly set-top boxes won't. So we've had some that won't.
There are a number that won't, yeah. The early ones would.
And we've seen the French adopt SR 1.5 2.0, 2/3, so it will do all of that down here.
Yeah. The nice thing about it, I would say this, wouldn't I? But you know, we're a local UK company. We're reactive and responsive to people's requests. If there's any sort of a sound business or even sheer interest case for doing things, we'll consider any.
Yeah, I mean, one of the things that impressed us about it was bizarre the way that I started. We started to talk to you, and at the same time, you were talking to Mark, G4WVU up in Norfolk.
Yeah.
And I know Mark because I'm from Norfolk as well. So I was talking to Mark about digital stuff and things. And one day he sent me a picture and said, next time you're up, I need to talk to you about this. I went, so I recognise that. And so, you know, we were working in parallel. And what Mark did, he actually did a full user review that was actually published in the mag this time round. But he had been evaluating it a couple of weeks before us. And the thing that impressed us was that he'd found a couple of snags which he talked to you about, Carl. And within a couple of days, Carl had done a firmware change, emailed it to him, The even more impressive thing was that Mark flashed his email, his DTX1, and it worked again. So there's clearly a level of support there that we perhaps wouldn't have got from other places. So no, that was one of the reasons that impressed us.
I like to think so.
Question?
Yeah.
Is it possible for users to plug reflashing DVB-T if you wanted to?
No. The reflashing takes place. Oh, by the way, in all of that spiel, I didn't mention quite an important part of it. There's a microprocessor in there, and the microprocessor is the thing that sets up the FPGA, and it sets up the A to D converters, and it sets up the synth. It sets up everything, and it scans the keyboard, and it drives the LCD panel and everything. But the reflashing it's a reflashing of that micro, whereas the FPGA is a factory fit thing, and that's it is flashed of sorts, but it's an E² memory device which is programmed up with the DVB-T image for the FPGA. Then when it boots, that image goes into the FPGA and then it runs.
Yeah,
but
and
that's
I mean, to be
get-at-able through the serial port.
And to be fair, from Antennair's perspective, they don't want, they're selling this at a good price. They don't want to erode the DVB-T market of products. So yeah.
Technically, you'd need quite a lot of kit to do it. As I say, you can't reflash it through the serial port. You'd need a in-circuit emulator type or JTAG type thing.
What's the frequency range RF output?
I have to think twice about this. Is it? I think it's 150 to 2150. But at either end, degradation of all kinds kicks in. It's really...
Yeah, you only guarantee it between
350
and 1350.
Yeah, but it will work outside of that range.
Motivation was for 77 and 23.
But then again, along comes somebody who says, "Oh no, I need it to work up at nearly 2 gigs, didn't I?"
Yes.
Because I wanted to transfer up to 3.4. So.
3.5 screwed up.
Yeah.
Well,
Now I'm very interested in what he was saying a minute ago. Yeah.
We've got a question from the internet here, which I think we've actually answered. But
right.
It says, any ideas for an ATV DVB-T version?
And the answer to that is no. Why would you anyway? The only reason why you would need to, and actually I'll come on to that in my piece, is the only reason why you need to run DVB-T is if you want to do mobile or heavy multipath environment. And they can always go and buy your standard product, your DVB-T standard product.
But it won't be 2 megabits wide. It'll be 8 megahertz channel bandwidth. Actually, it go down to 5, I think. Yeah. Okay. So
any more? But Brian?
There was a question on the forum about someone wanted a strange symbol rate, 4268.
yes.
The answer was you can only set it in hundreds.
Yes.
There are some UK repeaters that use 4167.
Yes.
So that might be a problem for them as well.
It might be, except Carl and I have just been discussing that before, because Carl's mobile is linked into the support email, and he got one this morning, didn't he? Well, in fact, 2 this morning. And we are looking at doing that now. We hadn't appreciated that there might even be a requirement for a fixed symbol rate. We just thought you get your set-top box and it can lock onto what you put into it. It never occurred to us that there might be such a requirement. Again, reflash it and we'll sort that with pleasure, but not necessarily today or tomorrow. Yeah. So yeah.
Okay.
Come and have a look
Any
at
more?
the real thing. Come and
Yeah,
look
the
at
demo's out. You're staying overnight, aren't
Yeah.
you? So they're around today and tomorrow. And we've got 4 or 5 units left in the shop. We haven't got any case parts left, unless you twist our arm to sell the demo one. But there are 5 units left. I'm amazed at the number of case parts we've sold. I was convinced we were going to sell the boards, but not the case parts, and it was the other way around. So we will be getting some more case parts in soon, and we've got some more units on order as well. So
they're being made.
They're being made. So the 4 or 5 units that we've got, which are PCB only in the shop at the moment, will be magically converted to case part ones when they arrive. Brian? No, you did.
So we priced them as two separate streams. That's a module with a case or a module without a case. And we've now sold all the ones with a case. There's a certain thought that we might rethink that strategy when we get new stock and sell modules with all cases. So that the people who may have bought a case, an uncased one at an earlier stage can retro buy a case.
Yeah, and
None of that's going out.
yeah. So Brian was just saying we could change it whereby we price it so you've got a price for the board and a price for the case parts, so you can buy either or. And the reason why we sell it like this is because it cuts down on assembly time and therefore cost, but also we're not selling a product, so therefore we don't have to get into CE and all of that crap. Okay, if that's it, I mean, I'm well impressed. That was bang on time.
Thank you all.
Oh,
Thank you.